Hey everybody, this is Larry. This is me trying to do day 9 of the Leetcode Day Challenge. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about today's problem. Right now my head is not 100%. I don't even know what that was, but apparently there's a lot of comments. So if this video sucks, check out that video from, I don't know, I guess not even a year ago. So check that video out. Today, I just came back from running about 10 or 11 miles. So I'm just very slowly, but I'm trying to ramp up there so I can do my 50 kilometers. What is that, 33 miles or whatever? So yeah, so I just kind of, need to do that. We'll see how that goes. But let's take a look at today's problem. Today we have 448 cave smartest in lexicographical order. Given 2 integers n and k, return the cave lexicographically smartest integer in the range 1 to n. Okay. I mean, I guess this is very similar to, or what was it? Is it yesterday's? Yeah, very similar to yesterday's problem. But of course, you can't generate all 10 to the 9 numbers and then get the thing because that would just take too long. But that's probably the thing that you have to do about it. And this is yeah, probably a couple of ways you can think about doing this. There's probably a binary search idea, but we're not going to explore that too much because I think the binary search, you still need to do some weird wonkiness thing. But the idea here is just try to figure out 1 digit at a time, right? Meaning that, okay, I mean, in a very basic way, we just go, okay, is the first number is the first digit of 1, right? And how, if given k is equal to some number k, right? Well, if the first digit is a 1, means that now you count all the possible numbers that starts with 1. So basically all the numbers that are before 2, right? In a way. And then now, you know that this gives you maybe, I don't know, let's just say f number, right? Now f numbers. And then of course, if f is greater than or maybe, I don't know, maybe you go 2, but let's just ignore the equal signs for now, because off by 1 is very easy. But let's say f is greater than k. Well, that means that the first digit is not 1, right? But if the f is less than k, that means that the first digit is 1. Let's just say for the purpose of this exercise, f is less than k. Then now we do the same thing, but we try with the second digit. Is it a 0? Is it a 1? Is it a 2? Is it a 3? And then maybe it's a 3. Then now is the next digit 0. Or maybe even no digit, of course. 0, 1, 2, 3, ... And then that's basically how you would come up with it. And the idea here is, or the rough back of the envelope math is that, of course, let's say it only goes up to 10 to the 9, so at most we have 10 digits. And for each of those 10 digits, you just do a loop for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that, roughly speaking, this is 10 to the, 10 times 10, not 10 to the 10. 10 times 10 times the cost of each calculation, which is how many numbers are in between stuff, right? And that's basically the idea that we're going to try to figure out for this problem. What I gave you just now is not... Honestly, it's not specifically to this problem per se, but it is. I mean, it is. It applies to this one, but it's not specific to this one, right? Meaning that similar ideas are for a lot of these problems where you can do it that way, and in that way, you can kind of see how it is similar to a binary search. Not quite. I mean, you could binary search on the digits, in fact, and that'll be slightly more, but increase the complexity by a lot, right? What I mean by that is that then now you can just, and I'm not sure that it is easy or possible, but you can say, okay, is the first digit a 5? Is the first digit a 2? ... Right? And then binary search on 10. Binary search on 10 is not worth doing, so we'll skip that. You can also do like maybe a true binary search, but that's just, there's a lot. I think it's harder than it seems. So yeah, okay. Okay, so that's basically the framework for how to think about how to get the number, right? But then now we have to figure out the function of, okay, of what we said, which is that, okay, if we try the first number as 1, how many, we have to answer the question of how many numbers are there with the prefix of 1, right? And then maybe later on, you have to ask the same thing, like 1, 2, then it'll be 1, 2, and then, 1, 2, 5 will be 1, 2, 1, 2, 5, right? So something like that. So you have to keep asking it. And of course, as part of this, you might start with this first, right? Dot, let's just say, right? And I didn't, I mean, you get the idea anyway. I'm copy and pasting. And that's really the core idea of how I want to attack this one. And the way that you would and that's basically the idea. Yeah. Sorry, I'm so tired, and we're getting an annoying problem. I mean, I think this is like, I mean, I feel like stuff like this is a core. It does come up a lot. Maybe not this one, but it's always very annoying to get right precisely, or at least for me. So I am very sloppy in it. I also like to do these with 0 index. So I'm going -1. And then there we go. Okay, so then now, yeah, so then now we just go for it, right? So, and this is, of course, all this is what, I didn't mention this, but all this is with respect to n, right? Because it matters what the n is. Because, for example, if n is equal to 15, then this is just 1, 10, 11, 12, 13, 14, 15, right? So 7 numbers. Of course, if this is even as simple as 18, then this is already more than that, right? So all this depends on n and so forth. Yeah. And then we can just kind of go through it, right? So let's. I mean, I think there are, I think one thing for these problems is that try not to prematurely optimize, because you might not need to, but we'll see. Yeah. We could even write. I mean, I was gonna. We could even write while true, because we don't know how many digits there are per se in the final answer, and maybe we could even say while k is greater than 0, right? Because the reason why I say k is greater than 0, because the way that I always structure it is kind of, it's not quite recursive, it's iteratively, but I think of it recursively, right? And what I mean by that is that, okay, let's skip to this for now. How many numbers are there with the prefix of 1? If k is greater than that number, then we have to ask how many, but this is after we subtracted from the numbers that are impossible anymore, which is 1. So then that's how I kind of think about it, right? Okay, so the current number is 0, say. Is it? I don't know. We'll figure it out. These forms are always very annoying. Yeah, and then now for the first digit cannot be a 0, right? But other than that, I think we're fine. Maybe it can be. I don't know. It just depends on how consistent you want to be. But because of this thing. But yeah, let's just say if I is equal to 0 and current is equal to 0, we just continue. Okay, then now we go. Okay. Okay, so given n, how many numbers are there with a prefix of current, right? So maybe we could write it that way. Current, because now we're trying to get 1 digit at a time, right? So then now maybe I would write something like, this is very awkward, but we just remove the last digit. Right, so maybe I just write times 10 plus I. This is very awkward, I think. I don't know. I don't remember how I did it last time. I didn't watch the video or look at the code. People sometimes say that I prepared for them, but if you watch enough of my videos, you know that I have no idea what I wrote. But so this probably looks awkward, right? So yeah, so then now now we update current first to set it to I, right? And then now we go, okay. This is very tricky, but let's play with some real numbers, right? So let's say n is equal to I don't know, 100, then and current is equal to say 1, and how many numbers are there, right? Yeah. Then okay. So maybe I have a function then, right? So let's just say f of current, right? So let's write the function because I wanted to manipulate current. That's why. So let's say we have an f, we have a current which answered this thing, and then now we go, well, yeah. And I like playing with all these random numbers just so I could like have a way to guide myself, right? So okay, so that means that so now it's kind of annoying because I want to do something like the length of stuff, but maybe that's fine though. But let's just say we have strength of current, so we get a length here, right? And then ln for length of n, right? Something like this maybe. I don't know. This is very awkward. I don't know. I'm trying to explain and solve at the same time. Like I know the idea, but it's kind of like tricky because I don't remember these things. But okay. So that means that, you know, let's say you have 1, right? So while L is less than Ln, right? Then that means that everything afterwards is free, right? So that means that here, if you have 1, then okay. So L is the current number of digits, right? So that means that okay. So that means that this has, well, if it's just how I want to structure it. Sorry if I'm not explaining it. Is that I want to say, okay, how many numbers are there with prefix of current? So I break it down by saying that of length of L is equal to say 1 digit. So 1 digit is going to be some number, 2 digit is going to be some numbers, and then dot dot dot. So then sum that up, right? And so maybe I could do a for loop instead, because we have to have at least L digits, right? Because if it's fewer than L digits, then it's just not possible because that's just how prefix is, right? And maybe we don't do Ln specifically because I think that's the tricky one. So then now here, if it's L, then so L minus I, if it's L, then it's just 10 to the power of that. So it's going to be, ooh, what the? So it's 10 to the power of this, because if this is 0, then there's only one way. If there's 2 digits, you can think of it as 1x, right? And 100, then of course there are 10 ways, right? And then now if it's 1xx, well, this one's a little tricky because they have the same length. So that's basically what I'm doing. So then maybe I have r is equal to 0. And of course, then maybe I see a pattern here with like 1s and 10s, but yeah. So then we kind of write this, but we should not prematurely optimize, right? Here, I think we can remove, you get the idea of it. So then here we get 1 digit is equal to that, and then it may be 0 and so forth. Because, for example, if your current is 12, there's no 1 digit solution, right? If the 2 digits, and so forth. Okay, so then now, what happens if you have this now, right? How many numbers are there? Well, I guess it's just 0 then, right? I mean, like, okay, so wait. So we have 1xx, not 1, 2. Sorry, I think 1, 2 is from something else. But let's say we have 1, then now 1x, and then 1xx. Technically, there's 1, right? But so that's 1. But let's say 2xx, that's just 0, right? 3x is 0. If we have 1xx and 1 is 154, then this is going to be 54. So then in a way, this is going to be current minus n kind of, right? Kind of, because it depends. Like if this is, okay, if n is 2, then what happens? Then this is 20. Right? So, and current is not, this isn't the right formula even, right? So basically you have, I'm trying to think for all the possibilities, that's all. I'm a little bit sloppy today. Basically, if this is 2 to 0, then this is, actually if n is greater than this, then all of these is possible, right? That means that it only matters if, like if this is 3, it's still possible, but okay, but if this is 2 and this is 1, then none of these is possible. So that means that maybe I could just say current, I want to say current times 10 or something, but it's something like power of 10 of ln minus L, right? And then current times this, right? So then now this gives us the same number of digits, right? So current is equal to this, say, and then if current okay, if n is greater than current, so if it's something like this, or if something like this, what would this? I mean, I get it, the answer for these specific examples, but I'm trying to come up with like a more general way that is a little bit more or less wonky. And there probably is, but I think it's just n minus current, and then min of this, so this has to be at least 0, of course, and then min of this, and but the most it can be is also something like this, yeah, right, because it is at most 100, right, for example in this case. So we can say it's this plus R, right? So maybe return this. And then once now, I don't know if this is quite right, we could play around, and in software engineering, what you would do is, of course, you just write a lot of test cases, right? And maybe even, I mean, this is actually not that friendly, test friendly, because you probably want the n as a variable to vary your test a lot better. But you know, but in theory, that's what you would do. So okay, so then now, if fc is equal to this, right? If fc is greater than k, then we are done. Then this is the current digit, so we continue maybe. Otherwise, k minus fc. Yeah, because then now that means that this current digit is the current thing that we want to do. And then at the end, we just return current. This is probably not right, but that's generally, I mean, or like off by something, but we'll see how it goes. This is, okay, well, I mean, if it's always off by 1, then maybe it's not so bad. Did I mess up by... Maybe I do count the 0. I usually hate doing it, but I think the way that I set this formula up, I do count zeros. But okay. Maybe not, though, because this is clearly very wrong. Alright, let's just go back to this one for now, and then we'll see. Alright, let's take a look. Why do I have 9? Given n, so... I don't think I saved this. I mean, I'm doing really weird things here. Okay, so it's continue, but kind of. So current is correct. So then now we actually want to shift by 10, maybe. Unless it is 0. If I don't know if this is even right, but okay, let's just say first is equal to false. If first and I is equal to 0, oops, it's true. Then first is false, continue, whatever, something like that. This, I don't even think this is quite right, actually. What we want is, if it's equal to 0, then we... Discontinuous wrong. I meant discontinuous and go here, but I meant break is what I meant, actually. Because I actually want to break out this loop to go to the next k. Maybe infinite loop now, though, because we don't have any base case. And also this would be now current times 10, maybe. Because now if this is bigger than that, then yeah, then it would go to the next digit. But clearly maybe we're a little bit wrong here. Okay, 110. Yeah, okay, I mean, at least it terminates. Yeah, I mean, okay. Just for laziness, if fc is equal to k, then we return current, maybe, right? I don't know if that's quite true. But yeah, but got this one right somehow. Okay. One is always going to be tricky. Output is 0. The first digit. Well, k is going to be 0. I don't know if that should be a 0. K is going to be 0. So then k, this loop never happens, and then I just return 0. So I guess that's fair. Let's just say if k is equal to 0, then we just return 1, because that's always going to be the case for every input. Am I confident? Not at all. But I am lazy, though, so I'm going to submit just because I want to get a wrong answer quick so that I can debug and not thinking about more test cases. Though I think, if anything, this is probably where the test cases should be, but maybe it looks like it's going to time out, so maybe I'm doing something funky here, which is also very likely, honestly, because I don't like the way that I did this at all. Oh. I mean, this is only the 4th case. I guess Leetcode is just slow today for whatever reason. We probably could have done that case though, 2-2. Okay, so output 1, expected 2. 1, right? So okay, so maybe we can... I don't like the way that I did this, honestly. That's why I'm like, very meh about it. If fc is greater than k, then this digit is I. So the fact that it doesn't print anything is actually weird. Oh, I guess it's just because it returns current. Oh, current, is that right? So it does the first number. So no, this f is equal to k is not right, I don't think. Because if it's equal to k, then it is the next number. So that it should have come here, and then now k is equal to 0. K is equal to 0, then it is the first version of that number. So then it's just equal to... I don't know. Maybe I'm just really wrong. All right, let's just see real quick. I feel like yeah, so the current, so we test 1 and FC is 1, so that's already this and it returns, right? So I don't think this is right. What we want is that now it decrements and then goes to the next number. That's what we want. So actually it should be this, and then it terminates because of this. But because it, what? How did I get 9? Oh, 2 is 0, 0. So then now if this should be if this is 0, I feel like I don't have current, but k is 0 to 0 is the more important part, right? Oh, I don't break here, that's why. I see. So maybe I have something like if k is equal to 0, if 0, we break something like that maybe. But we want it on the next I is the next I is the because we have to increment to the next I. Then what do you do if it's a 9? I guess it's not. It shouldn't be possible. But okay, right. So then now here we have 1 k is equal to 1. So then and FC. So then now this goes to 0. And then, oh, it goes to I is equal to 2, but then we don't try the prefix of this. So, okay, fine. Okay, so now this is good and this is good, but this is no good. Why? Okay, so 1, 1, and 4. Is that right at least? 13 is going to be 1, 10, 11, 12, 13 is 5, right? So that's already wrong. So that's okay. I mean, we're off by 1 because we miscounted on so like in theory this structure is more right. It's just that f of current is wrong then, right? Because you have 1, 10, 11, 12, 13, so 5, right? So I didn't make that up. I just say this is n. We only use it once anyway. So that make sure that I don't have any error. Okay, so then now we can do print of, what's it, 13.1. Whoops, I meant f of 13.1, of course. And this is 4, and it should be 5. So this is the unit test that we were that we should have is what we're talking about. Okay, but we can work through it, right? 13.1. Okay, so now this should add 1, and then now 13 minus 10 is the, oh yeah, no, of course it should be this plus 1 somewhere. Yeah, I mean you do the math, it's very obvious that it should have been plus 1 somewhere. Okay, so then that's good. So then now why is this still working for me? Okay, 115 for, what's the k? K is 2. So that means k is 1, okay. 115. Huh, actually the 5 shouldn't matter, even though we should have it fixed. But it doesn't affect the answer. I mean, well, you know, we need to fix that anyway. But yeah, so then now, so since this is true, we know that the first digit is whatever, right? And then now 10. I see. The thing is that when we increase a digit, or we set this digit, then now there is an empty choice, right? Of, this is the prefix, but that's it. There's no other characters, right? Because now we're already starting with, this already tries to add a digit, but here what we are saying is that we need to remove the empty digit of 1, or whatever the prefix is, right? I think that's where this is. Okay, so then here, maybe I do k increment 1. It is strictly greater than, n is not 0, right? So this feels hacky though, but yeah. I don't know. I mean, I think this should be somewhere, but I don't know if this is the place to be. But so this is adding a digit, a new digit. And if it's equal to, then so this has to be greater than 1, right? Because if this is 0, then this would have happened, and then we would have terminated at the next digit. Yeah. And if it's 0, then someone else would have gotten it. Okay, fine, maybe. For example, if we went to 125, then we have to remove the prefix. Okay, I mean, I don't know that this is right still, honestly, but let's give it YOLO submit. Oh, and I still printed stuff out. Why did I print stuff out? Where do I print stuff out? Oh, here. But why is K and why is there? This is negative is why, right? Yeah, I mean, I was wondering why we have fractions, but we have fractions only from here, maybe, and that's because we have negative, so power of whatever goes to negative. But how does that even happen? Oh, because of min of this, we thought that this would be okay. Well, let's just say. Wait, what is the input here? I mean, but this input doesn't make sense for this to happen unless I did something wrong, right? So, okay, so we have n is equal to n and a current. Because we do this, okay, that's fine. Why is that 2.1? What's ln and n? Three and 1, right? So that's 2, so that's 100, right? So how do you have 2, or is that r? Oh, I'm dumb. This is I and L. Huh, I have them in the wrong order. Okay. Alright. So that's a very silly mistake, but it seems like that fixed it. It's just that for some reason, that's a very bad mistake, actually. Alright, YOLO submit again. Oh, nice. There you go. So, I mean, I think we were close. A lot of silly mistakes. I know this is a little bit of a longer video and not like I think my thought process was okay, but as you can see, a lot of implementation details that are incorrect. And that's why I'm a little bit fearful of it coming in the beginning, right? It's just that there's so many ways to make silly mistakes, as you can see. And yeah, and this one is just the worst though, because I knew what I was wanting to do, and clearly that was negative, but yeah. I thought it was here, but which I don't know. But yeah, but that's, I mean, but that's what, practice makes it so that you don't make these kind of silly mistakes, but actually learning it correctly, and not, I wouldn't say correctly like there's only one way of learning it, but learning it correctly in a way such that you're able to come up with these things. I think technically speaking, I was right every step of the way, but you can also see my lack of practice in that, like, silly mistakes. And also just like very careless or very imprecise with how I defined this. That's how I was off by one here. But even beyond that one, I had to do this one. There are a lot of, I think you can write this in a cleaner way such that, like, this looks yucky as hell. So like you can maybe, let's see what I did last time. Is this cleaner? Okay, okay, I did crazy things last time, so maybe last time was not a great example either, actually. What about the first time I did it in 2019? 2019, I did it basically. This is more similar to the way that I did it today, but yeah. Oh, and I usually I add instead of subtract. I suppose, maybe, I don't know, but oh, and this is just so that I get the first digit. That's how I kind of took, instead of using this first thing, which is a little bit awkward, honestly. Um, oh, and then here okay, that's actually cleaner than the way that I wrote it here. Is that I just put it into the function of yeah, like instead of doing this, which actually is a very silly, weird way of doing it. If k is equal to 0, then yeah, current times 10 plus I, and then we break. Here, instead of doing this, we just do current times 10 plus I, try it, and then yeah, adding a new digit. So then now we just have something like this. Maybe it's off by something, but I think that makes more sense of the way that I wanted to write it over there. It may not be right because I think don't know why this isn't right though, actually. I mean, maybe it's like off by 1 somewhere I'm not being careful about. Yeah, I mean, this seems right. Right, yeah. This also seems right. This seems like it would be right? Yeah, we want to use this digit, maybe. Yeah, I don't know. It is very awkward, actually. Why is this wrong? Expected. And why did I output 1? After 1, 13, 1. Now I'm annoyed, honestly. I mean, I think the idea is roughly right though, but actually that's how I should have done it. Maybe I was more practiced at that first. But yeah, okay, so, well, this doesn't make sense anymore, so this is the prefix, right? So 115 is still same as before, so that's good. FC is 5, so then now we do this. So then now it goes to 1, right? And then we subtract the 1 prefix, and then now this is 0. So then now, I see. Huh. Oh, no, this breaks. So then now this breaks out of this, but then now, because of this subtract 1, now we are at 0. But this should be the 0 after we add a new digit. And now the digit is that this is 1, right? But 1 is not the right answer, Larry. What are we doing wrong? So this is 1, this is 1, this is 5, so that, you have this. We move 1 as the prefix, so then now it's the 0, but then now we break, but we want 1 more digit here. So actually, I guess we don't subtract this now anymore, right? Okay, maybe that's better. We have 1, 0. We removed this one, but I don't like the way that I handle this here either, to be honest. Maybe that's why, but because this by the time it gets to 10, it should be 0, right? So then now if you add 1 digit, it goes to -1. So this adds a new digit. We still want to remove the prefix, but we want to maybe do it here, right? Okay. But then now, if k is equal to 0, then we break. Otherwise we decrement. For someone like this, I think it's fine. Okay, now it's all wrong. Oh, I have to think if this is if not first to remove the prefix of 0 or whatever. It's still I would say even if this is accepted and this is accepted, it is still very much more awkward. To be honest. I kept the print, that's why it's a little bit slow. I don't know, but I think, like I said, like you have the idea, it's fine. It is definitely very awkward, and I didn't even need digit DP, which I did last time, I guess, in September. I think if you want to learn digit DP, this is probably interesting. And I'm sure I had much more. Wow, this is a very long code that I did last time. But yeah, so what's the complexity, right? Like I said, this one only loops 10 and this only loops every digit, right? Because we increase a digit every time. So this is like 10 times 10 times this function. And this function, of course, is going to be like d, where d is the number of digits. So it's going to be like 10 times 10 times 10, which is very fast, as you can see. And yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Thanks for the long code. Thanks for your support if you're still watching at the end here. Yeah. Let me show you. Let me just go over the code real quick. This is the top given this function, and this is the pause, and then this is the whatchamacallit. It's I don't know. Am I proud of it? Not really, but you know, when it's done, it's done. That's all I have. Thanks for watching. Stay good. Stay healthy to your mental health. I'll see y'all later and take care. Bye bye.